Okay, start marking that diagram up here, and we'll figure out what we need. It is pretty. These two are pretty intense. We're doing today. Okay. Here we go, kids. It is a two-part proof. Part A, we need to get BC and DA congruent. Can I just put that in step 2 and say parallelogram implies opposite sides congruent? Done. No, why not? What is in the givens? It's a quadrilateral, which, as you know, 4 sides, 360 degrees in their interiors. That's it. It's not a parallelogram, so don't tell me BC and AD are congruent. We need to get them congruent another way, though. That's still on the table. All right, well, think about what we've been doing all year, right? If I need 2 segments congruent, I got to find what? Triangles congruent. I need somebody right now. Name a pair of triangles, because there's only one pair that contain BC and DA up there. Name a pair that contain BC and DA as full sides, please. Yep, 7. Again, here we go. BC and DA. Yep, the ones that are right on top of each other. You get those congruent, CPCTC, we're good. Are we okay with the plan before we try to execute it? All right, proving those triangles congruent. What do we already have? I got B and D congruent. That gives me a pair of angles. I could also do what? Reflexive side. What's the reflexive side between the two? AC, all right. So I don't want to forget about it. We talked about it. I don't want to forget about it. So let's pop that in. AC congruent to AC, everyone's favorite, reflexive. So we got a side. Need something else. Because as you know, the third pair is usually the toughest, right? Is there anything up there that you see that I could do that would give me another pair of angles or sides? Whew. Sure you want to do this, Matt? I'll listen. Are those in the triangles, though? Oh, I'm not there yet, tough guy. Who are you going to vote for next time? Oh, yeah, you don't have a vote anymore. Sorry, too soon? Too soon? Sorry, too soon? All right, too soon. All right. All right. I'm glad no one's speaking up because there is nothing you can do. There is nothing you can do right now. So when we usually get to this point, I know some of you just give up, but that's not how we roll in here. After we've said, all right, I cannot prove those two, what do we usually go to? Find another pair of triangles that I can. And there are a pair of triangles in there that you can prove congruent right now. All right, name the pair of triangles that can be proven congruent. We'll get back to the other pair in a second. 15, what pair can be proven congruent? Yep. All right, I have 2 pairs of sides, and then I need to say the verts are congruent. Yep. So angle 1 congruent to angle 2. We're not forgetting about the 2 big ones. We'll get back to them. Vertical angles are congruent. That should seem like enough to say those 2 in the middle are congruent. Triangle FGC congruent to EGA. Need a method. Here we go. 15, again, why those 2 in the middle? Nice job, side angle side. All right, we just don't prove those 2 triangles to make our proof longer and hopefully we can get partial credit. There's a reason why we proved them congruent. Because remember, we were still missing something from my other 2 triangles. So do these 2 triangles have anything in it that I could use in the 2 bigger ones now? That would be my third and missing piece here. Take a look. The 2 triangles we just proved congruent, do they have anything in them that would also now help me with the 2 bigger ones I needed? All right, show off 13. Nice job, Natalie. Angle 4 is congruent to angle 3. Everyone see that they're in both pair? And Natalie, what's the reason they're congruent? Yeah, I remember the days you guys couldn't even remember it, and now it's just rolling off the tongue like it's no big deal. CPCTC. 1, 2, 3. And that was the missing pair we needed. So it looks like I can prove the two big dogs congruent, correct? I got everything now. You guys just got to give me a method when I'm done. Triangle BAC is congruent to, let's see, if I go BAC, DCA. All right, what's the method going to be there? I know I got a lot of arc marks up there, but 7, what's my method? Darn right. Let's go. You guys are like machines today. Angle, angle, side. Why did I prove them congruent? So I could say in part A, BC congruent to DA by CPCTC. Nice job, kids. Everyone count all right on those before I get to part B, which says prove the whole thing's a parallelogram now. Do not start over. Look at the work we've already accomplished. Maybe I can use that work to show it's a parallelogram. First thing, before I go absolutely nuts. Diagonals bisect each other? Diagonals bisect each other? Yes, no? Why not? FE is not a darn diagonal, so they don't bisect each other. Well, they do bisect each other, but it doesn't matter because FE is not a diagonal. All right, got to go somewhere else. What is your step you just wrote down? Okay, not the reason, the statement. Sorry. BC and AD, isn't that a pair of opposite sides? All right, so you got a pair of opposite sides already congruent. So I could do one of two things right now. I could prove that same pair what? Parallel, or I could prove the other pair congruent. We can do both. We can do both here. Easily, we can do both. Where are we going, kids? We're going to go parallel, or are we going to go congruent? I don't care what you think because I only care about what 7 has to say here. Hey, 3 in a row. You want to do parallel? Okay. We can do parallel. So Aaron said, let's prove BC parallel to AD. I think they are. Somebody has to explain to me why they are. I didn't write it down, but they are. 7! Oh! Correct. So we can say here, and if you want to go ahead and do it another way, that's fine. I'm fine with that. BC is also parallel to DA because alternate interior angles congruent imply parallel lines. And then in step 9, I think we have a parallelogram. I want to make sure we got the wording down, though. Here we go. Do we just keep trucking here? 17. Need the wording here, why that's a parallelogram. Not here. 11. There we go. One pair of opposite sides congruent and parallel implies a parallelogram. Hold on. I had a lot of people chirping up before Aaron decided to do parallel, chirping up, let's do congruent, congruent. All right, what would be the reason why BA and CD would be congruent? CPCTC. So technically, you did do one step longer, Aaron, because I could have just fitted in that step. So, okay, all right. The reflexive could have came anywhere. It had to come before I proved the triangle's congruent. It had to come before angle, angle, side. Didn't have to go in step 2, Logan, but it had to come before angle, angle, side. Because that was my side in angle, angle, side. Good? Anybody else? Okay, one more, then you're taking over. All right, one person saw it. Great. All right, here we go. ABCD, the full thing's a parallelogram. EF is congruent to FG. And now we had to prove the inner one a parallelogram. There may be multiple ways of doing this, but I'm going to do it one way in particular, so we know what should be going in our proof. So in that parallelogram in the middle of the ABCD, you already have EF and FG congruent. Is there any parallelogram properties we may be able to use from ABCD? I'm going to try to avoid proving triangles congruent here. Okay, maybe that's a way of doing it. I don't know, but I'm going to try to avoid that. I think that is a way, but because this is very similar to what you did on the homework. All right, everyone ready? I'm just going to lead you through this one. What can you tell me about AC and DB? AC and DB, tell me something about them. They're diagonal, so keep going. They bisect each other. So other than EF, other than DF and FB being congruent, what other pair is congruent? AF and, okay. Guys, look at my diagram. Look at your diagram. What's it in the middle now? What's ABCE right now? Look in the ABCE. What is it? Aren't the diagonals also bisecting each other in ABCE? Okay, so it's a parallelogram. Everyone see how I got there? But yeah, it sounds easy, but there's specific things you need in there. Okay, where did these markings come from? AF and FC. Okay, but that's not what I'm gonna write in step 2. All right, that's not what I'm gonna write, because the property, we listed 5 properties, correct, of a parallelogram. Yes? Did one of those properties say the little pieces of the diagonal are congruent? Did it say one of those 5 say that? No. What did it say? It said, what about the diagonals? They bisect each other. So that's what I got to write first, that the diagonals actually bisect each other. AC and BD bisect each other. That's the parallelogram property. Parallelogram implies diagonals bisect each other. Now you can tell me those 2 pieces are equal by a reason we've used all year long. Now you can say, hey, AF is congruent to FC. What's that reason going to be that we've pretty much used all year long that we just told us in step 2 there? 16. Definition of a bisector. Everyone see that? Look, you cannot put statement 3 with reason 2. We all good there? You cannot put statement 3 with reason 2. The only reason can go with 2 is that they bisect each other. Okay, it's a parallelogram now, right? A, B, C, E, correct? It's a parallelogram. What's your reason going to be then? Why are you going to tell me that's a parallelogram? Why is the one in the middle a parallelogram? What's your reason going to be? Come on, just shout it if you want it. Shout it out. What's the reason going to be? Diagonals bisect each other. You just told me that, but you told me it with your mouth, but did you ever tell me that in the statements? No. So you need to tell me AC and EG bisect each other. You can't just go right to a parallelogram. Oh, what's going to be a good reason? Remember, we just did this on homework. I gave Logan a real hard time about this. How do you know they bisect each other? What's up there? 19. Okay, 1 because EF is congruent to FG, but they bisect each other. So also AF is congruent to FC. There you go. Got to have these little details in there. Now that you said they bisect each other, now what can I call AECG? A parallelogram. And what's going to be your reason why it's a parallelogram to finish this? 3? Great job. Okay, all good. Half homework is out of the textbook. You're not touching that right now. You can touch that tonight. The other half is the 2 proofs on the next page, which you're going to discuss. Use your vocal cords with your group. If you are stuck, you call me over. If you want to know how many steps it should be, you let me know. I don't need to check it, though. I do not need to check it. Get going on it.